Hello, and welcome back to another one of my Maths Help videos. Today we're going to be looking at linear relationships, particularly focusing on completing a table of values and using that to complete a graph. So let's get started. To help us with this, we're going to look at the following problem. Kelly's Cabs is a taxi company that charges a $4.50 flagful, then a further $3.25 for every kilometre driven to the customer's destination. For part A, you need to complete the table below to show how much the total taxi fare would be after the distance from 0 kilometres to 8 kilometres. To do this, we need to consider the problem in two parts. The first part we need to consider is how much it's going to cost the customer for a given distance that they travel. To achieve this, we need to multiply the value that's costing per kilometre with the number of kilometres that they travel. For the 0 kilometres, we would need to be multiplying our $3.25 for every kilometre by the number of kilometres they travelled, which is 0. However, we also need to consider the flagful, which is the initial cost to the customer for entering the taxi. We need to add that flagful to our total distance travelled. So we need to add this $4.50 to our value that we've got over here. So our equation for our cost now equals $3.25 times 0 for the distance travelled plus our $4.50. $3.25 times 0 is 0 plus our $4.50. So therefore our cost for 0 kilometres is our $4.50 flagful. We then enter that $4.50 back into our table of values. I am now going to complete this process for our table of values here. After we complete these values like I've done in this table here, we can then represent these values visually on a graph. It can be useful to do this to identify if there is a relationship occurring between the distance and the total fare cost. If there is, we can then use this graph to visually answer further questions. Before I start completing the graph, I just want to point out a few things that every graph should have. The first thing it should have is a title for the graph. That title should start with figure and the number of which figure that is, as well as a general title. I've called this one Kelly's Cabs. The second thing that all graphs should have is a scale clearly listed and a label for each axis. On our y-axis, I've put our total fare cost, and I've also included the units, which is dollars. On our x-axis, I put our distance as well as the units is represented in, which is kilometres. The final thing that you'll notice that this graph has is a little arrow at each axis to indicate that these axes do continue. To complete this graph, I need to refer back to my table of values. I'll look at each column and consider each column to be a set of coordinates. I start with the distance, and along my distance axis, the x-axis, I find where 0 is, which is just here. I then find where the total fare cost for that $0, which is $4.50. I locate that and put a little dot or a little X where that coordinate is located. I'm now going to complete this for every set of coordinates that we have in our table of values. As you can see here, I've now included every coordinate that I had for my table of values. You can probably notice that it seems to be a relatively straight line relationship that's occurring between the distance and the total fare cost. Since I can see that, I'm now going to put a line of best fit that best represents this relationship. To do that, I get my ruler out. I don't just play connect the dots. I put this ruler that best represents a general line that fits what we see occurring here. As you can see at the end here, I've put a little arrow to signify that this line of best fit does continue. Now I've got this graph drawn, I've got a visual representation of how much is costing the passenger to travel a given distance. We can use this as a visual representation to answer questions like, how much would it cost for a 6.5 kilometre fare? To answer that, we look at where 6.5 kilometers is located on our x-axis, and we use a ruler to connect where that 6.5 meets our trend line. We then connect across to our y-axis to find out how much it would approximately cost at that 6.5 kilometer value. We find that it's just over $25. We can also do the reverse. We could answer the questions such as, if the customer had $15, would they have enough money to travel the distance to get back home if their home was 3.2 kilometers away? To do this, we could take it two ways. We could find where 15 kilometers is on our graph, and we could use a ruler. In this case, I've got a little grid line to help me, and connect it to our trend line. We then use our ruler to go down to our x-axis and find out how far you could travel for $15. In this case, it does look like it's just over 3.2 kilometers, so the customer should have enough money to get back home. Now it's your turn. Let's consider the following question. Belly is considering a rival taxi company, Red Taxis, who has a flag full of $3.50. with a further charge of $3.50 for every kilometre driven to the destination. I want you to start by completing this table below to show how much the total taxi fare would be for each interval in kilometres between 0 and 8 kilometres. After you've completed this set of tables, I want to challenge you with the following question. If Belly's destination is 3.5 kilometres away, which company would Belly be better off using? Red Taxis or Kelly's Cabs that we had earlier? To help you answer this question, I want you to bring in the same graph that we used for Kelly's Cabs. I want you to plot on the same set of axes the set of values that you got and put a trend line and see what you discover. As always, thank you for watching.